Hello, today we are going to be presenting about assignment one, or the Gamecock drone service. My name is Olivia Tranquina, and I'm one of four members of the Dream Team, with the other members being Austin Scorb, Ferris Al-Marhoobi, and Jake Rao. To just give a little bit of introduction to the scenario that we are going to be working on today, we are contracted by Gamecocks Drone Service Inc., a package delivery service company that uses drones to deliver their products. Our objective is to help Gamecocks Drone Service find the most efficient route for their delivery drones to take. So in this scenario, we're representing one city and the 125 drops that the drone will have to make in order to deliver about 1250 packages to 1250 people. So in order to do this, we're given a list of 125 XY drop coordinates. And our goal is to start at the headquarters, visit each drop location once, and then end at the same headquarters while minimizing our distance. The first step that we took when starting this project was to create a distance matrix that would serve as a resource, as referral for everybody who was working on it, no matter what methodology they were using. This distance matrix was also useful when working in Excel when using the indexing function, just so you could quickly refer back to the entire table and grab the distances you needed. So to create this distance matrix, we essentially put the drop IDs along the row 1 and column 1 of an Excel table, and then we calculated all of the distances between the drops and also the HQ location using the distance formula below and to the left. Below and to the right, you can see just an example of raw data and a distance matrix. It's unrelated to our project, but this is exactly what ours ended up looking like. It's just impossible to put inside the presentation because of the massive size of the file. To get a good idea of our starting point, without altering any of the data or any of the data order, we just created a table in which we could calculate the distances between each drop location and the previously visited drop location. And we did this by indexing the distances from the distance matrix. Then we summed the distances to find the total distance traveled. And this is going to be a very important future objective for all of our tests. So we found that the initial route, without altering any of the data, was a distance of 2,524.323. This is far above the optimal distance, so we have a long way to go, but also a lot of room for improvement. This is a very messy first graph of the unaltered data. So once again, this is just the data as it was given to us as headquarters, and then 1 through 25, and then back to headquarters. You can see here, you can see where the little clusters of points are beginning, but obviously there's a lot of crossover and there's a lot of room for improvement as shown by the actual distance total of over 2,000 from the last slide.
The freehand route optimization was an interesting measure because it allowed us to compare a human's visual sense versus a computed value. After printing out a copy of our scatter plot, I started at 0.11 and I traced the pattern I thought would be the shortest all-around distance. While tracing, I was careful to include every dot and make sure that I got all the extreme dots along the way. That way we had the most realistic results in terms of distance. Once I finished connecting the dots back to 1, I began recording my routes in Excel. And I did this by taking the package numbers that were already in Excel and matching them with the corresponding stop number that they were along the route that I drew. And these stops ranged from stop number 0 at coordinate 1, went down and around the plot back to stop number 125, which was also coordinate 1. And once this was done, I used the distance formula in the total column of the Excel datasheet to find the individual distance between each point that I decided to connect throughout the scatter plot. After that, I double-checked my cell inputs and made sure that I had 125 different stops. And once I did, then I summed the data in the column to get around a total distance of 770, which I thought was relatively small, at least.
So after doing the freehand distance calculation, we've moved on to do some actual data analytics. So we're starting to do this by using the nearest neighbor method, and also using the Excel solver to complete this. So in nearest neighbor, usually what you do is you choose any drop location, you determine the closest unvisited drop location, and you continue until all points are visited. And then you repeat the process starting at different locations. So because of the massive size of this data set, and generally the low accuracy of freehand nearest neighbor tends to be about 15% below optimal, which isn't great. We decided to use the Excel solver so it could run hundreds of thousands of scenarios. So to do this, we used the sum distance as the objective to be minimized. Our decision variables were our drop numbers, which were each linked to a package ID. And then our constraints were that all drop numbers had to be different. After running the Excel solver, you can see that our minimized distance became 845.33. So this is much better than the raw unfiltered data, but it actually is worse than the freehand drawing. So that just shows that this is our first computer generated answer, and it can only be improved upon. When it's plotted, it shows that there are definite improvement areas, such as right here, just places where it crosses, where you can tell that there's just a little bit of unnecessary movement, such as maybe here. So that sort of thing can be improved upon in the next step. Here you can see this is just pretty much the same visualization of the scatter plot with the solution that we found from the Excel solver. We just have a tiny bit of untangling here. And just by doing that, we saw the distance become better. It went from 845 to 829. So definitely untangling is going to be a feasible option as we move forward. So we're just going to put a little bit of effort on untangling these while keeping the main underlying patterns that the solver did create. Here you can just see a side-by-side comparison of the original scatter plot from the first solution with the solver, and now on the right, the basic outline of the original solution from the solver, but with some lengthy untangling so that there aren't as many crossed hairs. Just by doing this, but keeping the basic flow of the route, you can see that we've changed it from 845.33 to 663.45 in distance, which is an awesome improvement.
Hi, I'll be talking about the cluster analysis, our last solution. So I first ran a sum of squared error on the data to figure out how many segments would be the best option for us. It showed us that the fourth and fifth are most likely the best options. So I went with 5 segments. And in order to begin, I chose centroids that I thought were best based on looking at the data, and then found the mean location of those centroids. I then used the mean location of the 5 segments, the center point of the 5 segments, to come up with the new center of the centroids for the next time. And then I repeated this process 5 times to get the best 5 segments possible. I then went from starting at 1, 1, I went into the first segment, got everyone in the first segment based on closest distance. Then I went to the fourth segment, and then I took the top of the third segment where you see those outliers, went down to the fifth, on the right, took care of 2 and the rest of 5, and went back home at 1, 1. And this ended with about 684 miles traveled. So not the best solution, but definitely moving up.
In conclusion, we have ordered our routes from the most optimal to the least optimal, or from the shortest to the longest, with the shortest being the visual untangling at 663.45 and the longest being the initial solver solution at 845.33. It shows us how the traveling salesman problem can be tackled through the tech analysis but can also benefit from human-computer interaction. At this time, our team, the Dream Team, would recommend optimizing the drone path with Excel and visual untangling as it is our shortest possible route we could come with. Thank you. This has been the Dream Team.